Okay, in this video we have a couple more questions regarding simplifying rational expressions that come from the Khan Academy assignments. So I'd like to walk through a couple of these. Now I pulled this screenshot from the website and it looks like there's a display error here. If this happens to you, let's keep ourselves well aware that there should be a fraction bar between these two rows. And same thing with the answer choices down here. Now the question is, these two students manipulated this rational expression and their responses are shown below. So essentially when we manipulate, that means simplify. So they've simplified these rational expressions and one person got this answer and the other got this one. So let's see who was right. Well, let's keep in mind that anytime that we have a rational expression, it's really just a composition of a polynomial over top of another polynomial. So if we focus on one polynomial at a time, we should be able to factor them and reduce from there. Now there might be a tendency just to cancel out this 12n cubed and this 12n cubed, leaving us with 48n squared over 60n squared. But please don't do that. Remember, the only time that we can cancel factors from the numerator and the denominator, the only time that these factors essentially reduce to the number 1 is if these terms are separated by a multiplication sign. Both of these terms are separated by addition, so we cannot just cross-cancel. What should be done first, and again, this comes back to me describing this as a polynomial over a polynomial, is factor each of these individually. So let's pretend that we don't even have this expression on the bottom here. If that were gone and I told you to factor this polynomial, well, the only thing we can do to factor this polynomial is to find its greatest common factor, GCF. And the numerical component of the greatest common factor is a 12, and the alphabetical or the variable component is an n squared. They both have an n squared in common. So after I factor a 12n squared from this first term, I'm left with just a single n. After I factor a 12n squared from this, I have the number 4. Now, as it stands, we do have a term that multiplies by another term. We don't often write the symbol here, but there is an implied multiplication symbol. So if I have these two terms separated by a multiplication sign, and again a 12n squared in the denominator, as it turns out we do, 12n squared is common between these two terms, and we're left with n plus 5 this time after factoring. Now we've got two separate terms in the denominator, separated by a multiplication sign. Here's the time when we are permitted to cancel these two terms. The 12n squared divided by 12n squared factors to the number 1, and those can essentially cancel. But again, this is only done because of the separation by a multiplication symbol, not because of addition. So if I were to choose the correct answer on Khan's website, I would say that Naledi answered that correctly. But only Naledi, not Duru. And I did enter that answer off screen, and the website did accept it. So moving on to the next question, this is the other type of question you'll see in this group. The instructions simply say to simplify the rational expression. Now here again, if your display is a little bit off like mine is, let's remind ourselves that there is a division bar there. But I would do the exact same thing as before, and in fact I did create a video like this earlier this week, and you can find that in our Unit 1 folder as well in Schoology. But I'm going to look at this numerator, this polynomial up here, and I'm going to look for the GCF. And I know 2 can divide both of these, but a number larger than 2 that goes into both might be 4. So I'm going to use 4 as my common factor. I have a z that's common to both, so I'll call 4z my greatest common factor. And after I divide this term by 4z, I'm left with 3z. After I divide this term by 4z, I'm left with 5. In the denominator, the only common factor between z squared and 2z is the letter z. After dividing this term by z, I'm left with z. After dividing this term by z, I'm left with 2. Each of these terms are separated by multiplication, and in a sense this coefficient 4 and z are also separated by multiplication. So if you want to think of it as 3 separate fractions, you possibly could, and there's nothing wrong with looking at it that way. Anywhere that there's a multiplier that's separating some terms, we can we can create our own separate fraction here. I'll just use 1 as a placeholder. 1 times z is still just z. But doing it this way makes it really clear that the z's can cancel. They factor to the number 1. And we're finally left with 4 times 3z plus 5 over 1, which I don't need to write, times z plus 2. And I would argue that that's a good answer for the simplified form. That's what I would type in the text box. Now, the second part of this question does ask about which values of z makes the expression undefined, and essentially what this means is what values in the denominator make the denominator equal to 0. Because we can't have a denominator equal to 0, that would imply that we're dividing an expression by 0. We can't divide by 0. So lots of us recognize that if we look at this result here, after everything's been factored and simplified, we want to know the number that would replace z that would make z plus 2 equal to 0. So why not just create a small equation here, subtract 2 from both sides, and we know that z would equal negative 2. Or if z were equal to negative 2, then this whole group would equal 0. So that's our way of saying that in this in this rational expression, z is not allowed to equal 2. And so I would definitely choose that. But also let's keep in mind that the expression for which they're actually asking about is this original one back here. And negative 2 is not the only number that would make this expression equal to 0. Negative 2 squared plus 2 times negative 2, well, that's positive 4 minus 4. So clearly, a negative 2 makes that expression equal to 0. But also, there's another number. And we can spot that other number all the way back here. In our factored form of this expression, there was a second factor with the variable in place. If this variable ever equaled 0, in this case, z equals 0, if z ever equaled 0, well then it too would make this original expression equal to 0 in the denominator. 0 squared plus 2 times 0 is, well, 0 plus 0, which also equals 0, which we can't have. So not only is negative 2 a problem, but so is 0. And we know that because we've checked the factored form of the expression. So if you take anything away from this portion of the video, it should be that when looking for the undefined, or the values that make the expression undefined, check for those against the factored form of the rational expression, not the simplified form. This one is the simplified one that didn't give us all of the answers. This one is the factored form that worked. Well, I hope this helped. Please let me know if you have any other further questions. Thanks for watching.